This is part 3 of using the square root property of equations to solve quadratic equations, and we do the following 3 problems on this video. This is part 3 of using the square root property of equations to solve quadratic equations. So let's just do a review, and then we'll step up the pace and do a couple other problems. How about 2x plus 3 squared equals 12? All right, we've got it in a nice form where we have something squared equals 12, so we can go ahead and just use that property by taking the square roots of both sides. Remember, when you take the square root of something squared, you can write what's inside as long as you put plus or minus in front of the number on the other side. So I've got plus or minus the square root of 12. Now let's go ahead and simplify the square root of 12. Remember, 12 is 4 times 3. So you can take the square root of 4, that'd be 2 square roots of 3. Look back at my videos on radicals if you forgot how to simplify square root of 12. All right, now at this point we have two different equations. 2x plus 3 equals 2 radical 3, and 2x plus 3 equals negative 2 radical 3. You can go ahead and solve this problem keeping the plus or minus all the way through if you'd like this. So first I'm going to subtract 3 from both sides, but notice the way I'm going to write the negative 3 on the right hand side. We usually write it in front of the plus or minus. So I'm going to write negative 3 plus or minus 2 square roots of 3. And now that tells me what 2x is equal to. I'm going to have to divide both sides, the whole side, by 2. So my final answer here is going to be x equals negative 3 plus or minus 2 square roots of 3 all over 2. Now remember, that means there's really two solutions. Negative 3 plus 2 square roots of 3 all over 2. And you may not cancel those 2's, right? Because you'd have to factor the numerator, and 2 would have to be a factor. It's not a factor of the numerator. And negative 3 minus 2 square roots of 3 all over 2. Now, if this would have been like the square root of 9, you would just add a number, you would have broken this up into two different equations because you would have been able to simplify the numerator. You wouldn't have these radicals in it. Let's go ahead and check, let's say, the second solution in the original. You should always check your work, and you should check both solutions, but I'm just going to check one solution. So we have 2 times x. Now what's x? Well, x is this whole mess. Negative 3 minus 2 square roots of 3 all over 2. That's what x is. So I have 2 times x plus 3, and then the whole thing is squared. All right, so inside parentheses is just the number. I can't simplify within that, but I have 2 times that. Notice my 2's cancel. So now inside parentheses I have negative 3 minus 2 square roots of 3 plus 3. And then within parentheses, the negative 3 plus 3 is 0, so I have negative 2 square roots of 3 in parentheses, squared. Now when you square that, well, a negative times a negative is going to be a positive. A 2 times 2 is 4, and a square root of 3 times square root of 3 is 3. So I'm going to end up with 12 on the left-hand side and 12 on the right-hand side. So this was a solution. So my original solutions were correct right here. As long as I also check my first one. All right, here's one for you to try. Remember, first you have to isolate the thing that's being squared. Try it on your own. Put the video on pause. All right, so how do we need to start here? I'm going to have to subtract 3 from both sides, right? Because I need to have this right here by itself. So I've got 2x plus 1 squared equals negative 2. And we can do the square roots of both sides. And so when I take the square roots of both sides, remember you're going to have to put plus or minus in front of the square root of negative 2. Now, how do you write the square root of negative 2? You could write I square roots of 2 or square roots of 2I. If you write I after the square root, make sure you don't have the square root going out like that. That would be wrong. You have to have the I not underneath the square root symbol. Okay. Now, so far I've been solving these all as one big thing, but you could separate it out right here. You could say, well, 2x plus 1 equals the square root of 2i, or 2x plus 1 equals negative square root of 2i. It's up to you whether you want to write two separate equations here or at the end of the problem. Now I'm trying to solve for x, so I got to subtract 1 from both sides. So remember where we put that? In front of the plus 2 square roots of I, so I'm going to put negative 1 to both sides, so negative 1 plus square roots of 2i, and then divide both sides by 2. So one solution is negative 1 plus square roots of 2i all over 2. All right, the other one is going to look really similar. You're going to subtract 1 but from both sides also, but you're going to put the negative 1 in front of the minus square roots of 2i, and divide by 2. So we have negative 1 minus square roots of 2i all over 2. So this gives us two solutions here. Negative 1 plus square roots of 2i over 2, and negative 1 minus square roots of 2i over 2. Now, something to notice. Anytime you have a complex number like an I when you take the square root, or if you end up with a square root of 6, something that isn't a perfect square, like if you do square root of 3, that's one thing, but square root of 6, you'd be stuck with square roots in it. You'll notice the two solutions look almost exactly the same. They're actually conjugates. The only difference, there's a plus in front of the square root, and the other one will have a minus in front of the square root. And in that case, what I would usually do is just keep my plus and minus in front of this the whole way through, as opposed to solving it twice. But the final answer, make sure you do write it out as two separate solutions. All right, one more problem. Try this on your own. Put the video on pause and work through it. All right, how are we going to start here? Well, we're going to have to start by adding 1 to both sides because we want to make sure we isolate the thing that's being squared. So if I add 1 to both sides, we have x plus 5 squared equals 18. So then we could take the square root of both sides. Now, remember, you have to put the plus or minus in front of the square root of 18. 18 is not a perfect square. If that happens, that means this original problem could not have been done by factoring, by the way. If this was a square root of 9, it means you could have written the quadratic equation a different way and solved by factoring. But in this case, no way, so that's why we use the square root property. What's the square root of 18? 3 square roots of 2. Again, you have to remember, square root of 18 could be written as square root of 9 times the square root of 2, and that's going to be 3 square roots of 2. All right, so one last thing, subtract 5 from both sides. And remember, when you subtract 5, put it in front. That's just the way we write it. Really isn't wrong doing it the other way, but you won't ever see it written that way in a book, and it's just not a standard. So there are two solutions. Negative 5 plus 3 square roots of 2, and negative 5 minus 3 square roots of 2. So there are two solutions, and to make sure it's correct, you should check each solution in the original. I'm going to leave that for you to do this time. Next step, you want to look at my videos on solving a quadratic equation by completing the square. And we're going to be dealing with problems like this, x squared plus 2x equals 4, where if you subtract 4, you're unable to factor it. So we have a problem. How do we get it in the form just a squared equals b so we can use the square root property? The problem is I've got this 2x. I don't just have x squared plus 2, I have x squared plus 2x. So this is what we'll be doing on the next set of videos.